Hello and welcome. We're here today to talk about infrastructure edge and digital transformation. How does the infrastructure edge help with the sustainability that either will be served or hindered by digital transformation? My name is Daniel Hurd. I'm the VP of Product at Vapor.io. And Vapor.io offers neutral co-location at the network edge, and so this is a topic that we're always excited to talk about. Today, there's a couple of things that we had wanted to highlight. As we think about both the opportunities and the challenges, we thought it might be helpful to really take a step back and address why are there needs for the infrastructure edge? What is the growth that's occurring that we have to serve? What does digital transformation look like? Maybe touch a little bit too about what is the edge? There's many different definitions and people have used the term to mean different things. Then we'll also talk about what are the benefits that need to be delivered to enable digital transformation, what's driving this use, and what are the building blocks that are going to be required to make this all come together. It's no secret that mobile devices and the Internet of Things are driving a massive uptake of connected products. Everything from sensors to the most incredible AR, VR, and the proliferation of smartphones as a ubiquitous tool. All of these things are driving a massive uptake in devices that are connected to networks. These devices are increasingly the way that we navigate the world and understand the environment around us. Because these devices are used by us to navigate and embedded in the environment to help track, monitor, and control, they are also driving a commensurate amount of data. So the needs of the networks are changing rapidly from what they were originally designed for, which was essentially voice out in the open, to use cases that are far more complex and far more data intensive. If you're a company that's today embarked upon some level of digital transformation, whether it's your retail environment or maybe it's optimizing a supply chain or something as simple as having a better idea of what inventory you have and where is it in your stores, out in the field. All of these things are driving a massive uptake in the amount of data that's generated, when and how you need to get access to it, and where that data sits and where it needs to travel to. All of this change is also really taking place at a citywide level and at a countrywide level. So the scale of transformation is one of the things that has caused people to question, how will this help sustainability? How can we take advantage of this transformation to solve some of the broader problems that we're having? So many of the constituents are looking at a broad set of needs. They want to improve quality of life. They want to use these technologies to make all of us safer. It's a time of a lot of complexity and turmoil. These are some of the most powerful tools that we have. So it's really a compelling time to look at how can the edge infrastructure make a difference in our lives and make a difference for all of us in the days to come. Not just cities, but buildings, businesses, everybody is asking these same questions and really looking at the same building blocks to start addressing them. Those building blocks are the key criteria of ultra low latency, network connectivity as an intrinsic part of looking at infrastructure, the apps and content in media that ride on top of all of it, and of course, the distinction of having connectivity, whether you're inside or outside. Tremendous advances happening today in building wireless. And as the pandemic has really pushed people to work from home and to be much more flexible and thinking about what does it mean to have connectivity and where, we're seeing much broader needs for having a flexible way to serve everybody with the ability to reach the information that they need, whether that's a young school child or whether that's a building that maybe was super packed before and is temporarily empty, or conversely is a place that wasn't designed for much people capacity and is now being used by many different people for many different things. My own home is a good example of that. And the foundational challenge that we're collectively solving as we try and bring digital transformation into today's age with this incredible uptake of usage and data that we just talked about, is that today's internet is not built for these use cases. We really need a new internet. We need a foundational approach to tackle these core building blocks to solve for the problems that are facing us today. Well, what is that going to look like? What is this future that we are all collectively trying to build? It's a future that looks much denser and looks denser at the infrastructure edge. So as we're tackling these problems and as we're asking ourselves questions like, well, how do we make sure that we're being more efficient and consuming less energy rather than more? How are we taking better advantage of the infrastructure that we do have in place? This is a time when we really have to start thinking about building compute and building infrastructure that, number one, takes place as close as possible to where the need is, which is out at the endpoint device or as close as you can get to it. And it means finding efficient from a capital standpoint and from an energy standpoint infrastructure to serve those needs, which is down at the end of the edge of the network. So we'll talk a little bit more in this next section about the difference between the device edge, the network edge, and the data center edge. All of these pieces are needed to solve this equation. So if we look at the infrastructure edge, there's a couple of key benefits that we really have to keep in mind to ensure that we're delivering. As I mentioned, the edge is a term that has been used broadly, but in many different contexts. For people who are trying to optimize and really kind of transform their own manufacturing or delivery processes, the edge means their factory floor. For others, the edge can mean their home, their office, or the building that they serve with tenants within it. Others will describe the edge as a factory complex or a remote location that has complex needs in and of itself. Similarly, they could be referring to a citywide edge. And lastly, it's very common for people to talk about the edge in terms of a mobile device, an autonomous vehicle, a drone. The edge can mean also a complex device of compute that is existing beyond the edge of a fixed network and a wireless network. So with all of these things, what is the edge that we're solving for? And the view that we have is that you have to certainly have a holistic picture of what the edge means and have a clear understanding of it. The Linux Foundation and others have spent a lot of time advocating and creating a common taxonomy for this. And one of the things that is most critical and most needs to be clearly understood is the idea of the infrastructure edge. This is the boundary between the end of the wireless and wireline networks and the infrastructure that can serve it coming from central compute and cloud. For digital transformation, this is particularly important because so much of what enables the application experiences, the rich retail capabilities, and even the web and application level change that you think about when you think of digital transformation comes from a central cloud. But that transformation is happening at a device, at a point of sale, at a complex vehicle that's operating at the edge. So how do you bring these together? And the answer is what we call the middle mile or the infrastructure edge. So let's talk for just a minute about when we said that today's internet is really not going to serve these needs. Why is that? Today's internet was built for a world where a highly centralized core of that network is responsible for receiving, treating, and then sending back the content coming from these end devices. So if you think about the typical city, and let's in this instance imagine that the end user is using a smartphone and looking up a web service or an application on their device. Well, that signal will go to the nearest tower. The tower will relay it back to a central office to change it into an internet protocol message, which will then get transited back to a central data center, which will typically get moved again to a further centralized core, and that trip will then be repeated. This is the equivalent of trying to ship a package by first sending it all the way across the country and then having it routed back to you, which also can happen today. But it's tremendously inefficient and it won't scale. It's not going to deliver the benefits that are needed to enable digital transformation. And so what we like to think about is something that we call the kinetic edge. And this is what it can look like when all of the building blocks are in place to enable the greater network efficiency, the greater densification of compute down at the network edge, and the optimization of the traffic in between them. In this kind of topology, now you've got ultra low latency, you have a much greater reduction of traffic where only the data that needs to go where it needs to go has to be sent. So you can handle this density of devices and data that we spoke about at the beginning of the presentation. So this seems like a great picture. How are we going to deliver these sustainability benefits? Is this something that's going to take billions of dollars in decades, or is this something that we can tackle today? And our view is that these core building blocks to a sustainable infrastructure edge, the denser compute, the greater efficiency, the fewer trips, all of these things are really elements of using what is today available, but in a different way. And yes, it does require also new service development and new platform development. This is a space that Vapor is really excited to be leading the charge and pulling together a single platform to address all of these challenges. If you think about a traditional metro environment, I myself live in Seattle. Here's a little map of the greater Seattle area. What is this going to look like in Seattle's really dense topography? It's a city that's already very crowded, doesn't have a tremendous amount of space to go build new infrastructure. It's a city that has complex needs of different communities that are within it. And it's a city that has a tremendous amount of growth, while at the same time having a lot of challenges, particularly in the areas of sustainability and environmental efficiency. Well, the first thing we have to understand is what are the network boundaries of all these needs? Represented here by concentric circles, many of the different use cases and consumption areas have to be served within the physical limits of what is possible for ultra low latency. So in that instance, we're driven by the laws of physics. We need a network that is present within a specified distance, typically less than 5 kilometers of the endpoint. The second thing that we have to serve is the law of economics. We have to find a way to create this infrastructure that can be very capital efficient and that can be served to people in a way that they can buy it. Neutral co-location has proven a great model for that, not just in the data center world, but in the tower world, in really any aspect of infrastructure that you've seen. This is the drive that has really created it to be far more affordable. If you want to think even about a consumer example, what we call the sharing economy, everything from Airbnb to Uber, a similar move to take advantage of the infrastructure and assets that exist today, but enable the right level of privacy, security, and access through automation and digital transformation so that this infrastructure can be used at the right time, in the right place, in the right way. And lastly, the piece that is going to tie all this together is the fiber mesh. So having the 3 different components of the denser compute, in our case in the form of a micro data center, interconnected by fiber mesh so that you have the efficiency of being able to route the traffic when, where, and as it's needed, and located in the right physical places. These 3 things tied together are what we call the kinetic edge, and is the infrastructure that can allow for a sustainable development for enabling digital transformation. When all of this is pulled together, you see a complex topology that is capable of allowing customers to orchestrate their experiences to take place when and where is needed, not just in a single instance, but in a dynamic instance. So now you have the capability of orchestrating workloads for people congestion, for traffic congestion, for data congestion, for privacy, and for any form of control that is needed on a per application basis. This is a far richer way of looking at how to create an infrastructure to serve the IoT edge. So these are the key benefits that we're trying to serve as we think about how do we reduce traffic but increase the data center capabilities that today are both needed and just growing more rapidly. It's a world that's very beneficial to the data center infrastructure we have today for centralized compute that comes from the clouds that we're all living in and driving our services off of. This is also a way for us to optimize that compute down at the location where it can be served within a latency tolerance to create next level and future state different capabilities. The last thing I would say is that this is a great way for us to be able to have much higher utilization of the hardware that's already in place. So as opposed to having to densify the hardware that's on site, to have new endpoint devices, to have a very different end-to-end infrastructure, solving for the middle mile allows us to take advantage of what's already there to do so much more. The key building block that really brings this to life in a visible manner from Vapor IO is what we call our Vapor Edge module. And so here's an example of a data center that is built to run autonomously with the privacy, security, and control to enable that experience of multiple parties being able to use the same infrastructure so that it's the most efficient possible manner to bring the densest possible compute as close as possible to the end use application. So thanks for listening. This has been a description from Vapor IO of how we can solve for infrastructure challenges to make sure that digital transformation is happening in a way that's efficient and sustainable and able to really solve some of the problems that we're all tackling today.